Hi everyone, welcome to the video for Unit 2 Lesson 8, where we're going to now be working with some angle addition and subtraction. So what you're going to notice from this video today is that a lot of the stuff is very similar from what you did with segment addition and subtraction, but it's good to see some angle examples in here so that you can tell the difference. So the angle addition postulate, it says with this property what we're able to do is break up an angle into the sum of its pieces. So similar with segment addition, we were breaking up that segment into smaller pieces and adding them up. You can do the same thing with your angles. So in this case here, we're saying that if we take angle AGB, and then if we add that on to angle BGC, then what we would get is the value of the entire angle, right? It makes sense. You take two smaller angles and you add them up to get the entire value of the big one. Now again, it helps to, and maybe we can highlight AGC in green, that's the entire angle here. And it helps to assign some numbers to this, right? To kind of relate this to our algebra. So what we can do is if we say that angle AGB is 72, and then we say that angle BGC is 20, we can see that if we add those up, we would get the value of the entire angle here, which would be our 92. Okay, now again, make sure you guys are mindful of how you're naming your angles. They need to have your three letters, and the vertex has to be in the center, right? So in this case, it wouldn't suffice just to say, like, angle G in this case, because then I wouldn't know which angle you're talking about. So make sure you guys are precise in how you're naming your angles. Now we also have the addition axiom of equality for our angle. So if you remember, for segments, it said if a segment is added to two congruent segments, then the sums are congruent. Well, it's the same concept, except here we just have angles. So it says if an angle is added to two congruent angles, then the sums are congruent. Now, you guys are going to actually have to draw these pictures, so make sure that if you didn't already do that for angle addition, that you go back and do that now. So for the addition property of equality, you guys are going to have to draw this in, these three angles in for your angle example, and again, draw them in for your algebraic example. So if you don't have these drawn, you will not get full credit. So in this case, we're given that ABC, angle ABC, is congruent to angle DEF, so we want to label that. And now again, basically what this is saying is that it's saying, hey, if I take angle ABC and I add on the value of angle GHI, which is this lonesome angle like down here, if I take ABC and I add on GHI, that's going to be equal to the fact if I take angle DEF and add it onto angle GHI as well. Now again, what you'll see is GHI isn't changing, right? The measure of this angle is not changing, it's the same. However, what is changing is we have ABC being added onto it here, and then we have DEF being added onto it here, right? But we just said that these two angles are congruent to one another. So it doesn't matter whether it's ABC plus GHI or DEF plus GHI, since we know those angles are congruent, the sums are going to be the same. Now again, it might help to provide some numbers in here. So in this case, we have that ABC is 50 and DEF is 50. So if I rewrite this, if I did ABC, which is 50, plus GHI, which is 30, we said that that should be equal to doing angle DEF, which is 50, plus angle GHI, which again is 30. So if you check that out, you'll see the math works. We get 80 equals 80, and that is very true. So again, if the wording is confusing you, just try to either provide numbers in your angles to help you make sense of it. That's really the best way for me. I think that works, like comparing it to algebra. Now, with angle addition, we also have angle subtraction. Now, all this is saying is you're able to represent the angle by the difference of the larger pieces. So for example, let's say we took angle AGC, which is this entire angle. If we take AGC and we subtract angle AGB from it, if we take this angle away, what we're going to be left with is angle BGC, and I'll do that in green. We'll be left with angle BGC, right? And again, there might be cases in proofs where you need to be able to come up with an equation like this. And if you have to make an equation of this sort, your reason again would be angle subtraction. Same way, if you had to make an equation where you're adding up the smaller pieces to get the value of the bigger one, that's going to be justified by angle addition, right? Now again, providing numbers to this helps. So we're going to say that AGC, which is the whole thing, is 92. We're going to say that AGB is 72, and we're saying that BGC is 20. So if we do AGC, which is 92, minus AGB, which is 72, we're going to get that value of 20. And you can see that that's what we're left with here, right? So again, angle subtraction, we're just taking pieces away from the larger angle. And it might help to shade too. Like in this other diagram that we had here, when we actually did the subtraction, I shaded in what we took away, right? We did AGC minus AGB. We took this away. So if you shade it, you might be able to more clearly see what you're left with. All right, now we have subtraction axiom of equality. Now, this says that if an angle is subtracted from congruent angles, then the differences are congruent. Now, I use the same diagram as I did for the addition axiom of equality, where on the left we're given that ABC is congruent to DEF. And again, make sure you guys are drawing these diagrams so that you can get full credit. So what this says, if I take angle ABC and I subtract angle GHI from it, and then I take angle DEF separately, and I subtract angle GHI from it, what this says is, hey, these are going to be congruent. Now again, you'll see that GHI is the same in both equations. That value is not going to be any different. However, we have ABC and DEF are the only two different things on each side of the equation. However, we know that they are congruent to one another, so it doesn't matter whether it's ABC minus GHI or if it's DEF minus GHI, they're going to be the same value because those two angles are congruent, right? Now again, numerically, it might help us see it. So here we'll say ABC is 50, DEF is 50, and then GHI is 30. So if we said if we do angle ABC, which in this case is 50, minus GHI, which is 30, then separately that should be equal to the fact if we did angle DEF, which is also 50, minus GHI, which is 30. And it does turn out that those are the same. If you do that subtraction, you will get 20 on both sides, right? All right, now reflexive property is something, we did it for segments, we can also do it for angles too. So this property is used to say that an angle is congruent to itself. So again, you're using reflexive property if you have like an angle or a segment or any piece that is shared. So for example, we're given that angle DOB, which is this entire angle here, we'll do that in red. We're given that DOB is congruent to COA, which we'll do in blue. And then we want to be able to prove that DOC, which is the smaller angle, we can also name this like this is also angle 3 in the diagram, is congruent to angle BOA, which is angle 2 in the diagram. That might help you see it a little better. So what you should notice here is that this angle 1 here, let's do this in purple, this entire angle is shared by both of my given statements, right? So I know that angle COB is in both angle DOB, and it's also shared in angle COA. So if that's the case, if we have pieces being shared, we have to use the reflexive property to help us. So we would say angle COB is congruent to angle COB, and that would be our statement. Our reason would just be the reflexive property. And again, you have to do this when you're having a piece that is shared. And then last but not least, we have substitution again. Now, substitution we already know from algebra and we know it from our segments. However, the same thing is true for angles. So let's say that we knew that these two angles, angle ABC and DEF, were congruent. And then let's say using angle addition, we were able to make this equation where we have angle DEF plus angle FEG equals angle DEG. We can use substitution here. This given tells us that, hey, wherever I see DEF in an equation, I am able to swap it out or substitute it for angle ABC because those measures are congruent, right? So let's say at step 3 in my proof, I'm here, right? Again, here my reason would be angle addition. Now what I can do using my given information is rewrite my equation, right? I can swap this value out because I know that DEF is congruent to ABC. So ABC plus angle FEG equals angle DEG, and your reason would be exactly what you did, right? You just substituted, so substitution. Okay, so be on the lookout for that because substitution is going to help you get to your proof statement. All right, awesome. Thank you guys for watching.